Section 11-3 is on Mendel's laws. The first law, which we've already talked about when we talked about monohybrid crosses, is the law of dominance. And basically, a summary is that on a cross of parents that are pure for contrasting traits, only one form of the trait will appear in the next generation. All the offspring will be heterozygous and express only the dominant trait. And what it means by express is that is what you actually see. So if we take two pures and combine those two together, all of the offspring, the genotype, remember those are the letters, the genotype is going to be a hybrid, and the phenotype, you're going to see all of the dominant trait. So here would be an example if we looked at our monohybrid cross. If we combined two hybrids. So if we combined big Y, little y times big Y, little y, this is what we're going to get. We're going to get a 3-to-1 ratio. 3 yellow, 1 green, if two hybrids were crossed. Law of segregation means that during the formation of gametes, which are egg or sperm, the two alleles responsible for a trait separate from each other. And we demonstrated this also when we did the monohybrid cross. All alleles for a trait are then recombined at fertilization. Fertilization means that we have the egg and the sperm coming together. So that's what fertilization is. The egg and the sperm come together. So if this has a big R and this has a little r in your child, this is the trait that you're going to have. Applying the law of segregation. And there is basically what I drew on the previous slide. You've got the mom, and she is a hybrid. She has one of each, and in her individual eggs, one has a big T, the other one has a little t. In dad is also a hybrid. In one of his sperm, one has a big T, and the other individual sperm has a little t. So that when they make the children, these are the possibilities that could be seen in the children. The law of independent assortment, alleles for different traits are distributed to sex cells and offspring independently of one another. This law can be illustrated using a dihybrid cross. What this is going to mean is that if we had flower color and plant height, they don't stay together. They're going to separate independently, the traits are of one another. So in a dihybrid cross, it's a breeding experience that tracks the inheritance of two traits. Mendel's law of independent assortment states that each pair of alleles segregates independently during gamete formation. And if you remember, gamete formation is going to be egg and sperm, because gametes are egg and sperm. The formula, if you were to mathematically try to calculate, this is 2n, with n being the number of heterozygotes. So how many gametes will be produced for the following allele arrangements? So here's a little math added into your biology. Remember, 2n, with n being the number of heterozygotes. So here we have 1 heterozygote and we have 2 heterozygotes. So 2 to the second power equals 4. If we look at the next one, this pair is heterozygous, this pair is heterozygous, this pair is homozygous, and this pair is heterozygous. So this would be 2 to the third power, which equals 2 times 2 times 2. So that's 8. If we look at our third example, this is heterozygous, this is heterozygous, this is heterozygous, this is homozygous, this is homozygous, heterozygous, homozygous, heterozygous, and heterozygous. So if we count these, 1, 2, 3, 4, 5, 6. So this would be 2 to the 6th power, which is 2 times 2 times 2 times 2 times 2 times 2. And if my math is correct, I think that's 64. I could be wrong. So the answers: 4, 8, and 64. So that would be the number of gametes that we would get out of these particular combinations. And we're going to start to use FOIL that you had learned in math class. So how does a dihybrid cross work? The two traits that we're going to look at is seed shape and seed color. The alleles. Now, you'll notice as we're doing this, seed shape we're designating with the letter big R or little r. Seed color we're doing with big Y or little y. You're using two different letters because each trait, seed color and seed shape, each them have their own letter assigned to them. So what we're going to cross is heterozygous for round, heterozygous for yellow, times heterozygous for round, heterozygous for yellow. The gamete combinations, and the way that we do this is we take big R and big Y. That's where you're going to get here. We're going to have big R, little y. That's where you get here. We're going to have little r, big Y. And whatever letter you're always using, you put that first. So because we've used R first, we're going to use R first even if it is lowercase. And there's our big Y. And then the last one, we're going to use little r, little y, which is going to go right here. So it's kind of like you're using your FOIL in algebra class. So these are all possible gamete combinations. So how do we do the cross now? We start out with our Punnett square, and you'll recall that we had big R, big Y, big R, little r, big Y, little r, little y. Big R, big Y, big R, little r, big Y, little r, little y. These are our parents. That's mom and dad. And then we're going to be filling in our boxes. And how do we do that? We combine this R with this R. So we go big R, and then we combine these two together. Big Y, big Y. Big R, big Y, little y, because we have a little y right here. All right, I'm going to give you a minute, which might seem like a very long time. I want you to fill in the Punnett square. So that's what your Punnett square should look like. And I think you can see how that's done. You have to remember to keep the similar letters together and always list the dominant trait first. So once again, keep similar letters together. For example, big R, big Y, and always list dominant letter first. So if we have little r, we'd go big Y, little y. You always put, if there's a dominant between the two, you're always going to list that one first. This is our ratio as we're going through these. So if you look at this, this is round yellow. So we've got one, round yellow, round yellow, round yellow, round yellow, round green, round yellow, round green, round yellow, round yellow, wrinkled yellow, wrinkled yellow, round yellow, round green, wrinkled yellow, wrinkled green. So that's how we end up with our 9 to 3 to 3 to 1 phenotypic. And remember, phenotype is what it looks like ratio. And that concludes dihybrid crosses.